In this masterclass on unstructured data handling in Python, we will cover three key topics. Number one, handling JSON data. Number two, handling text data and analyzing text data. Number three, handling and analyzing image data. In 2026, these are the fundamental skills which will be your advantage in the data science market. Let's get started. Now, specifically, here's a more detailed look at what we'll do. With JSON files, we'll load a couple of different types of JSON files. We will infer the structure of it, infer the schema. We will then load it in Python and start analyzing or accessing data inside the JSON. We will identify the reviews data and extract it into a data frame, which we can further analyze. Next, when we have the data, we have the textual data for product reviews. We will analyze this text. We will first perform sentiment analysis using two different approaches. One, a classical machine learning based approach, which involves linguistics. Then we also use a transformer based model to identify the key aspects mentioned in the review. After doing so, we should be able to analyze, say, the sentiment scores by different aspects of the products. Finally, we will take a look at the image handling part, where we first extract various features from the image using OpenCV, the popular image processing library, and apply various mathematical functions really and extract features really quickly. Then we perform image classification using latest state-of-the-art vision transformer models from Google. Let's head over to Google Colab for this, and this is our playground now. Let's close this, let's connect to a runtime. You can name the file whatever you want, say unstructured, and so on. And let's straight away get started. For the JSON part, there are a couple of JSON files, which links you will find them in the description. I've added these two JSON files to the Colab environment, and as you can see, the customer reviews JSON and JSONL both are now available. Now, before I go further, I can view this JSON file a bit better. I can get a preview in Colab itself, but this preview is not really very structured, I would say. Yes, you can see loosely what's in there, but it's not really as structured as you might want. For a bit more complex JSON, this might be just useless. So we will view it using an online JSON viewer, which gives us a very good result. Let's go to jsonhero.io. This is one of the many online tools really. You can use this or some other tool if you'd like. And so you can enter a JSON here, or you could drop a JSON file over there. So let's just add our JSON file. And as you can see, the interface has changed. And now this is the navigator or the explorer for a JSON. And this is really cool. Now, what it tells you is there are four things in the JSON. Number one, there is this text, which is customer reviews, as you can see by the quote. So this is a variable name is dataset. The value is customer reviews. You can see on the right that this is text. And this is a string over here, as you can see. And the total reviews 35. This is just a number. This is an integer, which is a number. You can see here. And then products and reviews seem to be lists. So product has 4 items and reviews has 35 items. So if I go back to the preview in Colab, I see that yes, in the beginning of the data set, you do seem to have some metadata. So you have data set written here, and you have customer reviews. We have total reviews, which is 35. And then products seems to be a list of 4 different products. And reviews seems to be a much larger list. And each list seems to have inside it a dictionary. So let's take a look here in the JSON viewer again. Total reviews 35 is a number as we expected. Dataset is also a string as we expected. Products, let's click on that. Product, as we saw earlier, it had 4 different values. Each of them was a string. Wireless headphone, running shoes, coffee maker, yoga mat. And that's what we see here, 4 different strings, which is fine. Let's take a look at the customer reviews. Reviews, yes, as we expect, there are 35 in total, 35 different lists. What is in each list? Let's click on one of them. And each one of them has this structure. There is a review ID. There is a customer name, which is a string. There is a product description or product name, which is again a string. A category, which is string, rating, the review text, which is the actual review. Absolutely love these headphones. The sound quality is amazing and battery life lasts all day. Worth every penny. Date, whether it's a verified purchase, and helpful votes or not. If I click back, I can see these are the fields, and I could also see this in the JSON format, right? Which you could also see in Collab. If you click on the schema section, you'll see that there is a schema which has been inferred. It says that, okay, these are the fields in the schema, review ID, customer, and so on, and all of these are required. It also tells you what type each of them is. So review text is a string, date is date, and so on. This is the full structure and understanding of the JSON. And as you can see, this kind of tool is really very helpful, especially when the JSON is fairly complex. It's really hard to figure it out. It's very nested and it has, say, JSON inside of JSON and so on. So this is really very helpful. Well, now we know the structure. There are 4 things inside. One is a dataset name. There's a number, which is the total reviews. There's a simple list of 4 elements, which is the names. And then there is a list of 35 different reviews. Each of them is actually a dictionary, review ID, customer name, and these 9 fields in total. Let's go back to Collab and start working with this. Right, now we are back in Collab. I close this. What I'm going to do is, to work with JSON, I need the very useful standard JSON package. So just import JSON, and eventually I want to import this or get this into a Pandas DataFrame so I can analyze this much easier. So I'm going to do import Pandas as PD, and that's it. And let me just put it as PD, and we're done. Now, continuing. First thing you want to do is load the JSON file into memory. So we can call it whatever you want. We could call it data 0 if you'd like. And the simple way to load this, if you're loading it from a file, which is a JSON file right now, is just do json.load. If you were loading it from a string, you would do load s, but now we have a file, so it's load. And just do open here, and you can just give the name of the file. So say customer_reviews.json. So you have the JSON file here, you have the open, and that's it. Just run this and you should be done. Now, what is this like? Remember, this is a dictionary. Let's just confirm that. Type of data 0 is a dict. So when you load a JSON file using the JSON load function, it is converted into a dictionary. And the beauty or the benefit of having a dictionary is that in Python, you can work with dictionaries really very easily, identify the structure, get specific sub items, and so on. For instance, I want to know what are the different keys or different things inside the dictionary. I can simply do data0.keys. And what do I expect? I really expect 4 keys. Remember, data set, total reviews, these are a string and number, and this is a list of 4, and this is long list of 35 reviews. And I can extract specific items. So I could just do data set, data 0, and then I could do products, and this should give me a list with the names of the products. Let's test it out. Products, and sure enough, we have 4 different products. This works. And like this, if I just did data0.reviews, I should be able to get all the reviews accessed. So let's do that again. It will be a lot of output, but we can just see a few lines and then we can minimize this. So yeah, this is a list, as you can see in the beginning: review ID, customer, product, category, rating, and so on. So it's all there. This is good. This is one way of doing this. And once I have this in a fairly structured list, I could really move it into a Pandas DataFrame for analysis. I mean, I can still work on this, but this is really cumbersome, right? Looping over things again and again. So why don't I move it to Pandas DataFrame? So let's load it into Pandas. pd.read. What do you want to read? You want to read JSON? No, actually no. In this case, you have this thing in memory, so you could just do pd.dataframe, right? And instead of trying to give an object or something, you straight away have this reviews here, right? Just take this and put this inside as the argument, pd.dataframe data reviews, and this is structured enough, so Pandas will pick it really easily. So what I'm going to do is give it some name. So call it reviews 0, review 0 is pd.dataframe data review 0. Because this is well structured, what should happen is this entire thing comes into data frame very easily. So let's take a look at the head as well. Let's run this. And sure enough, you see review ID, customer, product, category, rating, text, date, verified purchase or not, helpful votes, and so on. So much better than working with individual lists and looping over things again and again, right? It's in a data frame, you could do whatever. Now, this was one way of doing this, and we used this JSON file. But there's another more, say, recently became a bit more popular, is the JSONL format. And this is really being used a lot, especially with LLM outputs. JSONL is similar, but just more structured. So we have the same data like before, but it already is very structured. So in the previous example, the previous JSON file, we had metadata as a separate section. This doesn't have it, right? This straight away has the full structured data. And because it is structured, you could already very easily load this into Python. So let's do it. Let's load the JSONL file. So let me write it over here, loading the JSONL file. JSONL is just JSON with lines in a way. So how do you do this? pd.read_JSON. This is the way. And you could simply specify the JSON file. It could be customer reviews.jsonl. So I'll just copy it from here again. Customer reviews.jsonl. And I need to specify that lines equal true, because this is in the lines format. So I could just call it reviews 0 again. It's the same data really. And I could say .head to make sure it worked. Run this, and sure enough, it worked. So the same data in a JSONL file, super simple to load. So that's it for the JSON part, right? You could see how we could very easily look at the structure and for the schema, visually explore it using a good JSON viewer. We could then load it as a dictionary and then access specific parts of the data. And if we have a JSONL format, we could straight away load it into a Pandas DataFrame. So why is this important? One is that JSON files are now everywhere, whether you're fetching data from the internet or some API that you're working and so on, right? Or maybe you're working with LLMs and so on. So JSON files are really important. Number two, this format that we saw with the JSON file earlier, with the metadata and so on, this is really a fairly common format you'll see these days when getting data from online sources. So you have some metadata, and there's a section then for the actual data. Even if you get data from Kaggle directly into Colab, you'll see a similar kind of structure. So it's good to work with the structure. All right, in this masterclass on handling unstructured data, which is essential for any data scientist in the year 2026, we will cover these few things, three main things. Number one, handling JSON files. Number two, handling text data and analyze text data. Number three, handle and analyze images. We'll also identify the main category of, we are working with product reviews here. So we'll also see the main theme the review is about. Let's get started. Let's continue with the text analysis part. We already have this textual data, which is product reviews, and we'll again perform analysis in a couple of different ways. Number one, we perform sentiment analysis using two different types of models. Number one, using an older, say more linguistics and statistical based model like TextBlob, and a new state-of-the-art model, which will be a transformer BERT based model. And then we will use a transformer BERT based model to also categorize or identify the key aspect in the product review. Now let's get into the code again, and just separate this text analysis section, so to say, and I will just enter this here so it's easy to identify. Now the text is available in this review text feature or review text variable in the reviews 0 data frame, and you can extract one of them just like this, review text and 0 here, and you get access to any individual text, right? So this is something you can easily access. So this is a pure string, absolutely love these headphones and so on. Now we will use two different methods. Number one, we will use TextBlob, which is a fairly old, 7 to 8 years at least, or 9 to 10 years maybe more, TextBlob for this analysis. And it's really handy, really fast, completely local, no APIs, no cost, really fast. So we'll do pip install TextBlob. And once this is done, you'll see how fast it really is. This is done. And once we have this, processing any text, like really any text, is very, very quick. Let me show you. Import, say, TextBlob. So from TextBlob, import TextBlob, which is the module to use. And once you have this TextBlob module, this is super simple to work with any text. So let's say I want to work with this sentence called "life is cool" or "life is great." Yeah, and I'm going to just enter this text, just supply this text to it, and just run this. Right, and you get this, but it doesn't show you much. But if I go here and I say polarity, so TextBlob processing polarity. Now you see there is 0.8. So TextBlob is giving you a sentiment analysis score, polarity score automatically. So it varies between -1 and +1. So if it with quotations and there's exclamations and so on, you say 1, right? Life is excellent is perfect 1. And if I say life is terrible, it should give you -1. So the swings between -1 and +1. Around 0 is neutral. So this is a very easy, very quick to use sentiment analyzer. We'll do this thing for the reviews data that we have. So for each review, we identify whether sentiment is positive, negative, or in the middle. We have a sentiment score essentially. To do so, we will first create a simple function. So get sentiment will be the name of the function, and we will provide to it some text, right? Sentiment, some review. And it's going to be really simple, really. We say you have TextBlob, and the sent will be supplied to it. And from sent, we have a polarity to be extracted, which is a straightforward number it gives back to us. And all you need to do is say return this. Or you could have done something else. If you want to process the scores further or divide into categories like positive, negative, neutral, you could save this in a variable and then put some conditions. Say return if sentiment polarity is more than 0.2, make it positive. If it is less than -0.2, make it negative. If it's between, call it neutral. You could do that if you'd like, but let's keep it simple for now. Just return this sentiment polarity, and done. This function is now available. Now to run this over the entire data set, you don't have to have multiple API calls or batching or any of those things. It's going to be really simple, really. You want to do something like reviews 0 dot review text, just essentially acts as a review text, dot apply. So this is how you can apply a function to the entire column. And you can say get underscore sentiment. Now this will return, of course, a full column corresponding to the original column, right, with the sentiment values. So you want to store it into a variable. You want to store it into a column now. Create a new column called sentiment. You can call it sentiment, or call it sentiment blob perhaps, right? And let's just run this. And let's take a look at this new data set, reviews 0.head. And that was really quick, right? It barely took a second. And you see, for each of them, there is a sentiment score. So 0.481 for the first one seems rather positive, great shoes for running, 0.53, the negative one's terrible product, -0.2, and so on. So yes, you do see the scores already. And as you can see, it was really quick. It was completely local. There was no API calls, no batching, nothing required. Very straightforward stuff. This is an older model, really quite old. It might not be the best in performance, but it can form a good baseline really quickly. So that was for method 1. Let's take a look at method 2. So let's call it method 2 using BERT or some BERT transformer based model or encoder decoder model, which is encoder is BERT. So that's okay. So let's do method 2, which will be using some BERT based model. Yes, so let's just call it BERT based model. And these generally are really good for the size. So they're really good performance. So let's find from Hugging Face, right? A BERT-based model, which is transformer model. And the way to do that is just import from the transformers package, import pipeline. And this pipeline is a really versatile, really very handy feature. You can take this pipeline and you can say, I want to do sentiment classification, I want to do any other thing, right? I want to do classification, I want to do something else, right? Different types of tasks, name entity recognition or some information extraction stuff. You specify the pipeline you want, specify the model you want, and it does the work. Let's see how. From transformers, import pipeline. We run this, and this will take a few seconds. Once you have this, you need to specify then the model. So I'm going to call it sentiment underscore model. This will be the model object. You'll call it pipeline, and you have to specify two things. One, what is the task in the pipeline? So sentiment analysis is my task. And secondly, you need to provide the model itself. And the model reference you can find on Hugging Face. You can also find it on the sentence transformers page as well. There's tons of models out there which you can use. And you can also see leaderboards, which model has what kind of performance on which task. You can go over there, see the size, see the usages and so on, and you can decide for yourself which model to use. The link is in the description. We will use Cardiff NLP, Twitter, Roberta, Baig, Sentiment Latest. This is a good model for a lot of tasks, especially I think things with user-generated data, with users speaking about stuff and whatnot. Language is not very structured or it's a bit casual. Then this works fairly well, right? So let's just use this as a good baseline. Sentiment model, this is a pipeline, and run. That's it. Now, this will download the model from the Hugging Face repository, and you can see here the model is 501 megabytes. So it's not huge. It's very easily fitting in RAM. 500 is very easy for modern systems now. Even your laptop, perhaps, it's super easy. So the model is now downloaded. It's fully on your machine right now. Let's minimize this. And now, once this model is available, using or passing any text to it is really as straightforward as what we did before, right? So you could just do something like, say, life is excellent. Or maybe it needs to be a list, but let's see. Yeah, life is excellent. The label is positive. Score is 98%. So it does do its job. And life is terrible. Maybe it gives you, minus 93%. Yeah, negative with the 92% score. So this is good, seems to be working, basic sense check. Now let's apply this to the entire data set, but for that we need to create a function. Let's create that function. So we'll say def get sentiment, and let's call it sentiment BERT, right? And we will supply to it the sentence, simple as that. Now what we need to do, sentiment model is the function, is the object to use. We will supply to it the sentence. Now we need to extract this label. That's it. Let's say you just want a positive or negative. Let's extract this label. And as you can see, this is a list. So if I want to get to the label part of this list, first I need to get to 0. So 0 will, the first element, right, of the list will be that dictionary. And within that, I need to get label. So let's just try it out. So there'll be label here, and then like this, I get to the actual label value, which is negative, right? So this is how I get to this. So I can take this, I can add it here. That way I get the exact label text, and I can just return this. So return sentiment model, this sent 0 label, and this should be it. This should be my function, which should do the job, right? So let's just run this. And as before, we just need to apply this to the entire column. So say reviews 0 dot review text dot apply, and apply this get underscore sentiment underscore BERT. This should give you it. And now let's assign it to a new variable or new column called sentiment BERT, right? This is just a positive or a negative value. Let's run this. This might take a bit longer than before. compared to the TextBlob, which was really instantaneous. This will take maybe 4 or 5 seconds. But still, this is done. This took 6 seconds, but this is still way better than going for a large language model perhaps and incurring a lot of cost. So this is it. This is done. Let's take a look at the dataset again. Review 0.head. Look at the top 5. And you had these text. You have the sentiment blob. You also have the positive or negative score. And eyeballing it looks fine, but of course, if you have actual label data, it is better to use this perhaps to just make sure you can validate that these are indeed working exactly how you want it to be, right? Or just get a sense of their accuracy. But in any case, it does seem to be working. This model is really good in general. So you can, for a baseline, for a benchmark, this is really very good to start off. Now, you have this sentiment score. And again, you are applying a 500 megabyte model, state of the art. You just import in transformers, and you see it took 1, 2, and 3 lines to apply this transformer model to get sentiment from it. Right? This is how cool this transfer learning is, and how easy it has now become to use any of these latest models with transfer learning. So there is no excuse to say I cannot handle text data. All right. Okay, let's continue. So we've done the sentiment analysis using 2 methods, TextBlob and a transformer model. Let's continue. Let's now identify the dominant aspect. Identify the dominant aspect in the review. So people are talking about various things perhaps, right? But I want to know, what are they talking about and what is it that they think about this? So let's say someone's talking about product quality. And are the reviews mentioning product quality in general negative, or are they more positive? So that I know that these are the areas I need to work upon. So let's do that. Let's try to figure out the dominant aspect. The first thing I'll do is write down what aspect of the model I want to identify. So, or let me just call it aspects. Okay? These are the things I'm expecting. These are the labels, these are the categories in which I want the model to categorize the different product reviews. Okay. Number 1, product quality. Another category could be pricing and value for money. This could be another category. Category 3 could be customer service and returns, or you could simplify this further really. In the reviews, you could say comfort and fit. You could then say performance and features. This is sufficient, I guess. You could add another category if you'd like, but this is okay for now. These are the aspects. Now, these will be supplied to the model as labels, and the model is supposed to say this is one of these 4. Okay. Now, for this, we really need to do a zero-shot classification, meaning that there are no examples you're giving it. It should figure this out from the data at hand. This means that there are no examples you're giving this. It should figure it out from the data at hand, remember. So let's continue. Aspects are here. Now we create the pipeline for the aspect. So aspect underscore pipeline or aspect underscore model, let's say, is using the pipeline function again. What is the task or pipeline for? It is for zero-shot classification. This is the task we are doing, and we need to specify the model. The model is, this time we'll use a different model, cross encoder. I think I'll just copy this, NLI. And again, like I said, like before, we could find out from Hugging Face or Sentence Transformer which model is good for this task. Let's just use this one. Now this one is 328 megabytes, and again, these are very small, right? For modern systems, they will easily run on your phone, be super quick and whatnot. So this model is also downloaded. Again, it is available. And as before, you could simply just say aspect underscore model. You could provide the sentence, you could provide the aspects, and it will give you a response. So for instance, let's just say that we supply to it first some sort of a fake review, say the battery life, or let's say the product fits really well on me, love it, right? This could be the fake review, and you could specify the different categories. The categories have to be provided as candidate, labels. Okay, and once you specify the candidate labels, which would be in our case the aspects, and this should give you for each candidate what the corresponding confidence score is. So this review, it is the highest probability of, let's say, label 1, right? And then the corresponding score, label 2 corresponding score, and so on. Let's just run this and see. Aspect model. Oh, there's a spelling error. So absect. All right, aspect model. I run this, and now I see this was the original sequence. The product fits really well on me, love it. But here, product quality. Product quality seems to be the best one, apparently. So product fits really well on me, love it. The second one seems to be comfort and fit, right? I mean, you could have said comfort and fit is the better one, but it chose one of them, right? But these are not very far away. You could also do something else, perhaps, maybe remove this, and you should figure out how it works for your case. So product quality, yeah. Maybe if you have different quality, different categories, it might be a bit different, but the size is perfect, maybe. And maybe it does a good job now. Let's just continue with this. And it says comfort and fit. Okay, this identifies it correctly. So anyway, you have this model. Maybe you could also find out some other models for your particular task, but I think they're good with this. Or maybe you could just validate the categories or change the categories that you want. This is good. This model is seeming to work fine. Let's now apply this for all the reviews. And again, if you remember, this is as straightforward as doing a simple function for it and then applying it. Let's create the function. So def get aspect, right? And the input will be the sentence. Let's define the function. It will be def get aspect, and the input would be the sentence. And this, again, you can use it from here, just copy it from here. You could have it like this. Instead of this hard-coded text, we will have sent, right? And again, you see here itself, there were different, say, labels available. You want to go to the first label value, right? So you want to go inside, you want to say labels, and this way you'll get all 5, but you want a first one, which is the highest probability one. You say 0. This will give you the label with the highest confidence. So this is the way to get to the result, and we add it here 2. This is it, and we just say return. That should be it. Let's try it out. How do we do this? Reviews 0 dot review text dot apply get aspect, and let's just call it something, say reviews 0 dot key aspect, maybe. Yeah, let's just call it key aspect. And let's just run this. Again, local model, really quick, should be done in a second or so. And once we have this, now we have done 2 different things. We have gotten the sentiment. We have also gotten the corresponding aspect in the review. And now, if you want, we could do something very simple, like, or some analysis, like identify for each key aspect, how many positive and how many negative reviews you have. So you could do something like p.pivot table, data is reviews 0, and then index would be what you want to put on the rows. You want to put a key aspect, and then columns would be sentiment BERT, and the aggregation function, or agfunc, or what do you want to be aggregated, is what do you want as the aggregation function, whether it's mean or sum or whatever. In this case, we just want the number of records, so it could be size, and this should give you this result. And we see comfort and fit as an aspect. In general, you see very positive reviews, right? 8 out of 10 seem to be positive. Performance and features also positive. Pricing and value for money also positive. But product quality, you seem to have more negative than positive. So this is something perhaps you should be very careful about, and maybe share this as an insight with the business team, and need to do something about it. But product quality seems to be an issue. Comfort and fit and performance seem to be fine. So this is good. And this is how you can now not only look at text, but you can extract key aspects, extract sentiments, and perform analysis on various dimensions now if you'd like, right? Maybe by product, by verified customers, and so on and so forth. So this unlocks text analysis for you. And we'll now do 3 things for understanding how to work with images. Number 1, we will load an image file and really understand the different channels in it and what an image file really is in Python. Next, we will use OpenCV, a very popular Python package for handling images, to extract some meaningful features from the image which we can use for further processing. Third, we will use a state-of-the-art vision transformer model which will help us to classify the content in the image. So the images are uploaded here. You can see there is an RGB image, which is the first image we'll use. Then there is another image for a blurry skyline. And we've just added another image corresponding to a fur coat. And you could also take a look at the preview of the image. So RGB image opens up on the right. You can see 3 sections. One is R, one is blue, and one is green. This will be useful for understanding channels in an image. Then we have the image of a fur coat. You can click and again try to see this, but it doesn't display very well, doesn't render very well because it's a WebP format. Anyway, you can still look at the skyline image. So this is a very blurry image which we will be using in a while. So let's work with images. Let's first load the RGB image. This will help us understand how the channels work. So first thing, we'll just import the libraries which we need. So we will need the OpenCV library, which is really powerful and really very handy. And you can do a lot of things with OpenCV. You don't need external packages for this. OpenCV can be imported as CV2. We may also need NumPy, but let's see, maybe we won't, but let's import it anyway. NumPy is NP. And just for the purpose of, say, visualizing, for easy visualization, so you want google.colab.patches, import cv2.imshow. This just makes sure the images render well when you display them. So that's that. So let's run this, and the packages are in. Now, let's upload the pie, the colorful pie. And to do so, you just do cv2.im read. This is very easy, simple to use method. So of course, just like any regular file, cv.im to show it PNG. And once you've uploaded this image, or once you have imported this image, you can just do pie.shape because you need to understand what this is. Or let's just do this first. Let's just get this in. Now let's see what the type is. Type of pie is, well, it's a NumPy array. And what is the shape of this NumPy array? It is 316 by 314 by 3. So almost a square, but 3. Right? What is this 3 for? All these three correspond to the various channels. So there's a red, there's a green, and there's a blue channel. Every image you see is made of these 3 channels, RGB. That's why you have these RGB colors and so on, and RGB codes and stuff. Anyway, let's split this image. What we'll do is we'll split the image into the different channels. So BGR, this is just the convention which is used in CV2. We can take any image, CV2 we can do a split, and you can provide the original image. So this very simply, what it does is takes the image, and it's a matrix essentially, right? And just divides into the 3 different channels, BGR, and done. And just to make sure this has done its job, what we'll do is we'll plot, right? We'll plot, or we'll visualize the, say, red channel. Now what should happen, from color, this has become individual black and white images. Yes, when they come together, they form color image, but when they're individual, they're just, say, black and white, right? It's just about whether the R intensity is low or high. So when I plot this only R, what should happen, or what I'm expecting really, is the R part should have a high number and it should be white, because high numbers, when you display images, they become white. 0 or low numbers are black, dark, right? So when I plot this, it should appear so that our part, which was red, the red part should appear white and the others should appear black. Let's go ahead and do this. And sure enough, you see this part is white and the others are black. Just to confirm, you could also look at G. So just add another cell instead of R, make it G, and the G part should be white and the other two are black. So you can pause a moment here and just make sure you got this. But essentially, an image is comprised of 3 different matrices. Each matrix corresponds to a channel, red, green, and blue. And if you try to plot them, they are all just intensities between a minimum and a maximum, typically 0 or a 1 or 0 to 255 as well. Yeah, so that's what an image is comprised of. And of course, you can add them together, get them back into a single image. So that's what the original image was. And just to be sure, you can also take a look at the dimensions of individual images, right? This is 316 by 314. So just confirms that these are 3 different matrices which come together in an image. So that's what an image is made of. But in general, you don't need to worry about handling each channel separately, because most of the functions or most of the packages we will use will handle the image in its entirety. So you don't need to worry about separating into channels and operating on individual channels. Right. Let's then continue, and let's now extract features. Now imagine that we are working in an e-commerce company and we have various article images, images shared by the seller, and we want to use these for, say, listing on the website or in the ads we show on the platform and so on. Of course, image quality has a role to play. If the image is not good looking, maybe the chances of clicks are lower. Something that is blurred, something that is washed out, the chances of it being clicked are a bit lower compared to something which is a nice and sharp image with the right amount of brightness. So let's do that. Let's talk of extracting image features, right? Features from images for, say, some sort of a modeling. And for this, we will use the CV2 library. And we will see that this part, again, you don't need very sophisticated models. These things are fairly mathematical in nature. And you'll find that they are straightforward commands for this. So some of these commands you might not understand right now, and that is fine. These will be shared in the notebook, and the notebook is at the link in the description. Feel free to copy the code from there, and this is enough. Okay, so the image we will use for this part is the webp, the furcode.webp file. So let's just give it some name, give it some path. Image path equals furcode.webp. And once you've done this, you can just load the image. So cv2.imread and image underscore path, just to make it dynamic. Okay? Now with this, the image should be in. And let's take a look at the image. cv2._imshow image. And you have this big fur coat image. You could also perhaps specify the dimensions of this. But anyway, I think that's not too important at this point. Now, you can fix the size as well. But this is an image of a fur coat, as you can see. And we will try to extract features for this image, like some things around the quality of it. Things like, say, what the brightness level is, what the blur level is, and maybe something around how the edge density is. Higher density means more detail. So let's go with this, and we'll compare it with another blurry skyline example, right? So first thing we could do is let's get the overall brightness. So let's just make it brightness. And this is again rather straightforward here. This is just some standard stuff, so you don't need to worry about what this is exactly. But of course, when you're using this, you should know how it works. So this is the way to calculate the brightness. So you get gray, and then you have the mean of the channels and so on. Let's get this, and you see there is a brightness score 212.1. This is the brightness score for this image. Now, let's continue. Let's get another couple of scores. One would be the blur score. So this will be done using the Laplacian. Let's get this, get rid of this as well. And this is just the standard way of calculating a blur score, right? Which takes a look at the variance of the Laplacian and so on. Anyhow, let's calculate the blur score, and you get a value of 151.3, right? So these are standard features, straightforward. You don't have to really think a lot on this. Just use these formula. Blur score is 151.3. Now, a low blur score means higher blur essentially, and a high blur score means the image is a little bit clearer. So in this case, the image is not too blurred, which is good. The third thing we'll look at is edge density. So you find out how many edges there are using a particular filter, and then you find out what is the edge density. And higher means more edges or more detail. And for this, you have 9.8. So there's three numbers you got, and because you could very easily get these are rather quick as well because they are just mathematical functions. You could wrap them up in a function as well. You supply an image, you get all three values back, and you could do that for all the other images in a folder or all the links to images in a data frame and so on, right? Now let's do this thing just to make sure we understand this, or how this works. Let's do the same for the other image, which is the blurry skyline image. So I'll just copy this file name here and replace that for code webp reference with this. And we read this, and it helps to remember the previous values. This is a fairly blurry image. This is of course also much darker than the previous one, right? So let's see what brightness score we get. Remember, we had 212 earlier. Let's see what we get this time. 117, roughly half. Blur score, right now 151 for the fur coat. What is it for this image? 67, again less than half. So obviously it is very blurry. And finally, the edge density, this should also be significantly low. Let's run this, and you have 4, again 9.8 to 4, significant drop. So as we can see, these features are capturing information about the quality of the image, and they can very well go into a model which is around the overall quality score, or into predicting whether this image will be clicked in a marketing campaign or not, and so on. This is really valuable stuff, and this unlocks a lot of things for you already. Now let's go to the fur coat thing again, put it back here, and we'll perform the next task with the fur coat image. Let's do the final thing, which is classifying the content in the image, right? The image, so the article in the image in this case. And this is an image classification task. As we did earlier, this will be super simple. We will use a state-of-the-art model, transformer model, a vision transformer model from Google. And again, we need to give it a name. Classifier is a pipeline, yes? As mentioned earlier, we need to specify the task and then the model. The task here is image hyphen classification, and the model we'll use is the Google model for vision transformer. So this is, I'll just paste it here, BIT base patch 224. Again, there are many different models out there. You can try something else out if this doesn't work best for you, but find the models for your use case. There's plenty of them and different leaderboards and scores. So let's run this and let's see how big it is and how much time it takes, right? So let's run this model again, load this model again, and we have a 346 megabyte model, and it's done. So now we have this model in our notebook, and let's see if it works. Now, I will simply supply classifier. To this, I will supply the image path. That is all I need to do. Again, 2 lines. Let's run this, see what I get. Now, again, similar to the earlier format, I will get the labels and their corresponding scores. So the thing which has the highest probability comes up at top. And if I only want the top one and just the label, I could simply say 0 to get the top one. And if I only want the label, I would just say label. And again, it's done. So we have used a vision transformer model from Google to classify the content in the image. Now, if we had different product images, let's say 1,000 of them, or maybe 10,000, we would go through them one by one in this manner. And because this is a completely local model, it won't cost you anything other than the basic compute cost, but it won't cost you anything in APIs. You don't need to figure out batching and the other stuff. And this will give you a good result, a good baseline result very quickly. So this is the power of transfer learning. And as you saw, even images are not really too difficult to handle in Python. We have really handy libraries like OpenCV, and because of transfer learning, we have state-of-the-art models easily available to you to be able to use them in just 2 or 3 lines. If you have made it this far, then congratulations, you have done really well. You did so many things. You handled JSON files, you explored their structure and inferred the schema, you processed different types of JSON files in Python and prepared them for analysis. You extracted the text content, the reviews data from this JSON files. So you're ready to handle JSONs now. Then you analyze the text data which we had gotten, the product reviews data. You performed sentiment analysis using 2 different methods, the older classical method and using a transformer model. Then you also used a transformer model to identify the key aspect in a product review, and eventually you analyzed, okay, which aspect has what kind of overall sentiment in a way, which is more negative, which is more positive. This is really valuable stuff, which is, you can imagine how valuable this can be in any e-commerce company or for any company which is looking at, say, social media, how the customers are responding to social media, or perhaps how they are, what their brand voice on social media is like. Finally, you went towards image handling, where you extracted features from images using CV2. You also saw how it structured the different matrices and the channels and whatnot. But you also saw that with just a few lines of code, very quickly some mathematical formulae, you can get things like blur levels and brightness and edge density and so on. And then you also performed classification of the image using a vision transformer model from Google. So you did really well, and I'm sure you found this very useful. A small request is, if you like this video and if you have made it so far, then please encourage us by hitting the like button and subscribe to this channel so that we know you're finding this valuable, and we'll make more of such videos. And what should we do next? Just let us know in the comments so that we can maybe take that up as a next video. I'll see you in the next one.